So in a previous video we talked about how we can use ease to generate parametric tables that allow us to explore how a dependent variable changes as you change an independent variable. And we used this particular problem to illustrate that process. And again, this is exercise 2, question 1 in the Easy On-Ramp course, and it shows the process of solving a very simple dynamics problem where a pulley is being used to lift a mass. So we wanted to explore how the radius of the pulley affects the acceleration of the mass, and to do this we generated a parametric table, which I'm going to do again here, that includes both the parameters r sub p, which is the independent parameter, the pulley radius, and a, which is the acceleration, which is the dependent parameter. And then we set the values of r sub p to run from 0.02 meters to 0.2 meters. We commented out the value of r sub p in the equations window and ran the parametric table. And the result is shown here. You can see the numerical value of acceleration that corresponds to each value of the pulley radius. So this type of parametric study is most easily shown using a plot. And this video presents the basic steps that are used to generate a plot in ease. Ease allows the generation of several types of plots. In this video, we're only going to cover the most basic XY type of plot. And we're going to plot data contained in this parametric table, but you should realize that data contained in lookup tables, arrays, or integral tables in ease can also be used as the basis of a plot. So when you're ready to generate a plot, you select New Plot window from the Plots menu, and that will bring up the New Plot Setup dialog shown here. At the top of the dialog, you can provide a title for your plot in the tab name field here, and if you'd like, you can provide some descriptive text. The upper right portion of this dialog is used to select the source of the data. So here we're going to use a parametric table, and the name of the table containing the data is shown here. Here we've set this up to plot all 10 rows in the table, but it's also possible to plot only a subset of the rows if you'd like to do that. These two windows in the dialog allow you to specify what variables will be the independent or x-axis and the dependent or y-axis data. So here we're going to plot acceleration as a function of pulley radius. And when that's all set up, we'll select OK, and that will create the plot. In the professional version, which I have here, you'll notice that variables could be plotted in either their base or the alternate set of units. So here, for example, the pulley radius r sub p has units of meters, but it also has alternate units of inch, and so I can select either of these two to make the plot. Almost every aspect of this plot can be modified in order to customize or improve it. Only some of the most basic options are going to be described here. So when the plot toolbar is shown, the plot and the objects associated with it can be moved around and repositioned. So here you can see that I can grab the axis labels, for example. I can move them around. If the plot toolbar is not visible, then I can't do that. And you can toggle the plot toolbar on and off by selecting Show or Hide Plot Toolbar from the Plots menu. If you double click or right click on either axis label, you will bring up this Format Text Item dialog. And in this dialog, you can change the axis label to whatever descriptive text you'd like. You can add units, you can change the font, you can change the font size, and so on. When the plot toolbar is visible, you'll see this gray triangular icon at the bottom right-hand corner here of the plot. And you can use that to resize the plot. So you select this gray triangle, and you hold the mouse button down and move the mouse to an alternate location, and you'll see that the size of the plot changes. And also notice that all the text and the graphics items on the plot are resized in proportion to the size of the plot. If you'd like to avoid that, so resizing all of the items on the plot while you resize the plot, you can do that just by holding down the Control key as you resize the plot. You can adjust the scale of the plot. To do that, you place the mouse over any of the axes, so left, right, bottom, top, and click the right mouse button, and that will bring up the Modify Axis dialog that's shown here. And that's going to allow you to make adjustments to the axis scale. You can add grid lines and so forth. If you want, you can actually hide the scale completely, as shown here. You can change the axis starting and stopping values. So again, you can do that from within the dialog itself if you'd like, or you can do it on the plot itself just by holding down the left mouse button on an axis. And if you do that carefully, you'll see that there's this double-headed arrow that appears. And if you move the mouse, you can see that what I'm doing actually is changing the axis start and stop value. What else can I do here? I can change the automatic scaling option, and that will cause the axis scale to automatically adjust itself to encompass whatever data is being presented. And then I can actually adjust this scale by 10 to the power option. And so if I want, I can scale the numbers here by 10 or 100 or 1,000 or so forth. So here if I select 10 to the first, you'll notice that now all of these numbers on the label are being scaled by a factor of 10. I can even, if I want, select the top to bottom option here, and that'll invert the axis, so run it the other direction. Alright, multiple data series can be overlaid onto the same plot. So for example, I might want to also see how the tension in the cable changes with the pulley radius. And to do that, then what I would first need to do is add the variable f sub t, so force in the cable, to the parametric table. And then I'll have to run the table again. And now I'll select overlay plot from the plots menu. Not new plot, but overlay plot. And that will allow me then to add another plot to my existing plot. So in this case, I'm going to plot f sub t as a function of r sub p. And you'll see that now my plot has two curves. Of course, this is a little bit of a problem because the tension force and the acceleration have very different values, at least for the units that I've chosen. And so it doesn't really work to use the same scale for both of these quantities. So one thing I can do is give one of the two quantities an alternate scale. So if I double click on the plot itself, you'll bring up this modify plot dialog, and this is really handy. What you'll see here in the upper window is every data series that's plotted on this plot. So there's two of them for me. So I can change how they're plotted. Down here I can change what symbols are used, lines, smooth them, etc. One option that I can use here is to plot one of these two data series on a secondary y-axis that has a different scale. So in this case, I'm just going to plot the force of tension on a secondary y-axis, and I'll adjust the scales now so that both sets of data are shown clearly on this plot. Alright, finally, because we have two sets of data, we probably ought to label them so we can tell the difference. And the easiest way to do that is to select the text item from the toolbar, and I could add a label. So maybe I'm going to add the word acceleration, and if I want, I can add a legend symbol down here and match it up with the acceleration data set. And let's do the same thing here with force, and we'll move these two labels off up into the corner. Maybe align their left sides by selecting them both and selecting the align tool, and now I have a nice legend telling me which data series corresponds to which quantity. Alright, there's a whole lot of other stuff you can do with plots in ease, and we'll cover some of these in other videos, but this should get you started with generating a plot in ease.